In this video, we're deriving the formulas for the derivative of the tangent, cotangent, secant, and cosecant based on all this other information. So in the first box, I'm showing the basic derivatives of sine and cosine. In the second box, I'm showing how all these other trig functions could be defined in terms of sine and cosine. Notice that these are all quotients. And then in the third box, a reminder of the quotient rule for taking derivatives. So when you differentiate a quotient of two functions, you start by differentiating the numerator. You leave the denominator alone in that first term. You subtract the term where you leave the numerator alone and differentiate the denominator. Then you divide the whole thing by the denominator squared. So it looks like we can get the derivatives of all these other functions by applying the quotient rule to the definitions of these functions in terms of sine and cosine. So let's get started. So the tangent is just sine over cosine. When I differentiate, I have to apply the quotient rule. So I differentiate the numerator. Sine differentiates to cosine. I leave the denominator alone. That gives me another factor of cosine. Then I subtract the numerator left alone. Derivative of the denominator, which is negative sine. And divide by the denominator squared. Our numerator can be re-expressed as cosine squared x. And then in my second term, I have a double negative, so that's plus sine squared x divided by cosine squared x. At this point, you have to remember that cosine squared plus sine squared is a trig identity. That's actually equal to 1. This is just what you get from applying the Pythagorean theorem on the unit circle. The length of the hypotenuse is 1. So I end up with 1 over cosine squared x. But 1 over cosine, as I can see from the second box up here, is just the secant function. So this is the square of the secant function. And now I know when I differentiate the tangent, I get the square of the secant. The second derivation is very similar. This is the derivative of the cosine over the sine. When I apply the quotient rule, I differentiate the numerator, giving me negative sine x. Leave the denominator alone. That's another factor of sine. And then I'm going to subtract numerator left alone, derivative of the denominator, which gives me another factor of cosine, all divided by the square of the sine function. Factoring out a negative 1 in the numerator, I end up with negative sine squared x plus cosine squared x. And there's that identity again, all divided by sine squared x. So this is negative 1 over sine squared x. But then I see the cosecant function is 1 over the sine function. So this is actually the negative of the cosecant function squared. Next, I'm differentiating the secant function, which is 1 over cosine. Now, one approach to this is to use the quotient rule, where the function in the numerator is 1. Another option would be to write it as cosine x to the negative first power and use the chain rule. Whichever way you're more comfortable with is fine. I'm going to go ahead and use the quotient rule on this. Derivative of the numerator is 0. Just to be thorough, I'll throw in the denominator left alone. Minus numerator left alone, derivative of the denominator, which is negative sine, all divided by the square of the original denominator. So this term with a 0 in it dies, and I'm left with a positive sine divided by the square of the cosine. And you could leave it that way, but more typically, we would split off a sine x over cosine x, recognizing that that gives us a tangent. And then we're going to have a leftover 1 over cosine x, which is a secant. And it's normally written with the secant first. So secant x, tangent x. In the final derivation, we're trying to find the derivative of the cosecant function. So that's 1 over the sine function. We apply the quotient rule to this. Derivative of the numerator is 0. Denominator left alone. Minus numerator left alone, derivative of the denominator, divided by the denominator squared. Again, that 0 containing term dies. And I have negative cosine x over sine squared x. And so this is negative cosine x over sine x, 1 over sine x. And this first piece is a cotangent, and the second piece is a cosecant. This is normally written as negative cosecant x, cotangent x. So we're done getting formulas for all the other trig functions. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.